So we have already talked about conservation of momentum when we said that according to Newton's law, sum of forces equals dp over dt, and when sum of forces is 0, then dp over dt is 0, which means that P is conserved. That means P initial is same as P final. And this lecture will talk about impulse, the case when when summation of F is not 0. So let's talk about just one force, and that can certainly be generalized to many forces. So let's say we have this object. The case of many forces is just addition of all the forces. So whenever we have we want to go from one force to many forces, then all we have to do is sum over all the forces, which means vector sum all the forces. So what we have here is this body, which let's say is moving along the x-axis, and let's say it has a momenta pi, and then all of a sudden you start applying a force F on it. And let's also assume that this F is changing in time. It can change in space also, which means it can change with x also, but let's assume it's changing with time. Then we know that that force is because dp over dt. Then we can say that dp equals f dt, right? And we can integrate that over, let's say we started at time t equals t1 or ti, and we ended at time t equals tf. So we can integrate that from ti to tf, and that gives us p equals, well actually pf minus pi equals f dt, right? You may be a little confused, but this is what we mean by the left hand side, right? And this is the right hand side. So we see that pf is not same as pi now. Pf is not same as pi now. Pf, in fact, pf minus pi is equal to t1 ti to tf f dt. So there's an increase in momenta of the particle, and this thing is called impulse. It's called the impulse. So let's do an example in the same lecture. Let's say we have a ball, and this ball drops down from a height 1 meter to the ground and hits the ground elastically, which means it hits the ground and does not lose any energy in the process, which means if it hits the ground with a velocity v, it rebounds back with the same velocity. If it loses energy, that means the rebound velocity is less than the incoming velocity. So let's assume it's not losing velocity or losing energy, and the mass of this ball is 0.1 kilograms. And this whole collision process, let's say takes 0.1 second. Now first of all we have to calculate, and let's make further assumption, one more assumption, that during all this time the floor, when the ball is colliding with the floor is going to put a force on the ball, because the force that is going to change the impulse. Let's assume force put put does not sound to be a very good word, but let's use put by the floor is a constant, so it does not change with time, just a number. Okay, so the first thing is how much was the impulse provided by this force. This is this. Sorry for the bad handwriting. Okay, just to clarify you, what is happening is this ball drops down, and as it hits the floor puts a force on the ball, and because of that force the ball rebounds back. That means the momentum changes. Okay, for the sake of simplicity, let's assume g to be 10 meters per second square. So what is the impulse provided by the force? Well, whatever impulse it is just Pf minus Pi. So Pf minus Pi is the impulse. And again, let's say we have to define the direction. Whenever we are dealing with a vector problem, we always have to define an axis system. So let's say this is the y-axis. If this is the y-axis, what is Pf? Well, you see the final Pf. First of all, let's calculate the velocity. What is the velocity of this object when it drops down here, from here to here? And we can use one of the kinematics equation, to calculate that the velocity when it hits the ground is going to be 2gh. You can use one of the kinematics equation and calculate this. This is what it will turn out. That just before it hits the surface, the ball has this velocity, which is same as 2 into 10 into 1, which is square root of 20. So this is the velocity by which it hits the ground. So what is Pf? Pf equals, you see velocity is pointing upward, the final velocity. So momenta, which is just m times Vf, is also pointing upward. So it's a positive vector because y-axis is up. What is Pf? Well, the mass of the ball is 0.1, so it's 0.1 multiplied by 20 and kilograms meters per second. This is Pf. What is Pi? Well, Pi, you see, is pointing downward and is the same value as Pf, because we said that the velocity, the magnitude of velocity was not lost. The energy was not lost, and magnitude of incoming and outgoing velocity are the same. Thus, the only difference is that Pi is pointed downward, so that means it's minus 0.120 kg meters per second. So what is Pf minus Pi? Well, you see it's going to be 0.2 square root of 20 kilograms meters per second. So this is the impulse, and you clearly see the net change of momenta is actually in the upward direction, because this guy was innocently coming down, but it was rebounded back upward. So the net impulse was actually provided upwards, which is this value, right? And all this came from here. Now the other question can be, what is F? What was the force that was provided by the ground? We do not have much space left, but let's squeeze in this small space. Okay, so what is this value for a constant force? What is this value? Well, if F is constant, you can take F out, and the term reduces to T1 T2 dt, which is same as F times the change in time. You see, this is nothing but change in time, and change in time, we already said, was the whole collision took 0.1 second. So it's 0.1 equals Pf minus Pi, because that's the left hand side. So 0.220, and that gives us, if you just solve it, let me do it faster, and this should give you 4 square root of 5 newtons, right? Okay, so I hope it helped, and we'll talk some more examples in the following lectures.